Find all complex zeros of the polynomial function, give exact values, and list multiple zeros as necessary. Here we have f of x, which is equal to x to the fourth plus 8x cubed minus 8x squared plus 96x minus 240. So here is our function. So the first thing we want to do is we want to figure out what are all the possible rational zeros of this function. In order to do that, we need to figure out what represents p and then what represents q. Okay, well, p represents the constant. So we're going to put in plus or minus 240 because it can be either plus or minus 240. And then the value of the leading coefficient represents q. Okay, now we're going to write down all the factors of 240. Okay, so all the factors of 240, so let's go ahead and list them. Okay, when we list them, we do the following. We know that 1 and 240 gives you 240. 2 times what gives you 240? Well, that's 120, right? And the way to do that is we can just go ahead and use a calculator here. 240 divided by 2, right? 240 divided by 3, right? So 3, that's 80. And then 240 we know is going to be what? 4 goes into 240 60 times. And then 5 goes in 48 times. Okay, then what about 6? So 240 divided by 6. That gives us 40. So 6 and then 40. And then what about 8? So 8 goes in there 30 times. Okay, we know 7 doesn't go in there. Does 9 go in there? No. What about 10? Yes, because 240 divided by 10 gives us 24. So 10 and then 24. Okay, what about 11? 11 doesn't go in there, but what about 12? So 240 divided by 12 gives us 20. So it's 12 and then 20. Okay, what about 14? We know that 13 doesn't go in there. What about 14 divided by 14? No. 240 divided by 18 doesn't go in there. 240 divided by 19, and that doesn't work. So we can go all the way up to, let's say, 24, right? So let's see here, 24 divided by 20. Does that work? Yes. So we know that 12, 20, 10, 24, so we have all our factors. So that means that all the possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 3, all the way to plus or minus 240. So these are all the possible rational zeros. Okay, so we need to pick one of these zeros to determine if it's a factor or if it's a zero of this polynomial function. So what we can do is the following. To kind of shorten our time, we want to make sure we can graph this to see what it looks like when we graph it on Desmos. So let's put this graph in Desmos, okay, and we're going to go ahead and put this in. So we have x to the fourth plus 8x cubed minus 8x squared plus 96x minus 240. Okay, so now let's take a look at this graph. Right, so here's what our graph looks like. All right, so it looks like there's a number here and then there's a number here. Okay, now when we see the graph, right, when we look at this graph, there are two zeros. There's one at -10 and then there's one at 2. All right, so what that means is by just graphing this, we've determined that these two are zeros of the function. And if you take a look at that, okay, 2 is one of the zeros of the function, and so is -10. Okay, because remember, this is plus or minus. So just to confirm that we get a remainder of 0, we're going to plug that in. So we're going to take 2, okay, and then we're going to factor it into that polynomial by using synthetic division. So the leading coefficient is 1. We have 8, -8, 96, and negative 240. Let's just confirm that we get 0. So we're going to bring down the 1. 2 times 1 is 2. 8 plus 2 is 10. 2 times 10 is 20. 20 minus 8 is 12. 2 times 12 is 24. 96 plus 24 is, let's see here, that's 10, 9, 10, 11, 12, that's 120. 2 times 120 is positive 240. So therefore we get a factor of 0, right? Or excuse me, a remainder of 0. So what does that tell us? Well, that tells us the following. We know that, again, we're confirming that 2 is a 0, which means that x minus 2 is a factor. Okay, so now that we know that x minus 2 is a factor, okay, now we need to look at this. So since this is a degree of 4, this is going to be 1x cubed plus 10x squared plus 12x plus 120. So now we have x minus 2 times x cubed plus 10x squared plus 12x plus 120. Okay, so now we need to take a look at everything up to 120. So what are all the possible rational zeros for 120? So that means if we wanted to then figure out what are all the rational zeros for 120, so 120 represents P, and 1 represents Q, and we already know what that is. We know that it's going to be plus or minus 1, plus or minus 2, plus or minus 3, all the way up to plus or minus 120. Okay, so that means that everything up until 120, so 240 is not part of that, but everything from here up to 120 are possible rational zeros. Now, you can see here that negative 10 is the other 0. So what we're going to do is let's confirm that. So we're going to confirm that negative 10 is a 0 of this function here. So we have 1, we have 10, we have 12, and then we have 120. So let's go ahead and confirm that. So bring down the 1. Negative 10 times 1 is negative 10. 10 minus 10 is 0. Negative 10 times 0 is 0. 12 plus 0 is 12. Negative 10 times 12 is negative 120, and that gives us a remainder of 0. So what does that tell us? Well, now that tells us that negative 10 is a 0. Okay, and therefore x minus a negative 10 is a factor, which means that's x plus 10. Okay, so that means in part 6 we have x minus 2 times x plus 10. Okay, and then we're going to take a look at what we get here. So since this degree is 3, then this is going to be 1x squared plus 0x plus 12, which means that becomes x squared plus 12. Okay, now that this is the factored form, now we need to find the zeros of the function, because that's what it asks us, to give the exact values of the zeros of the function. So we're going to set this equal to 0. So that means in part 7 here, we're going to let x minus 2 equal 0, or x plus 10 equals 0, or x squared plus 12, which is equal to 0. So we know that x is going to equal 2 here. We know that x is going to equal negative 10. Or here, we subtract 12 to both sides, and we get x squared, which is equal to negative 12. And then we're going to take the square root of both sides. So remember, that's plus or minus the square root of negative 12. Now keep in mind here that this becomes the square root of 4, which is a perfect square, times the square root of negative 1, times the square root of 3, which gives us 2i times the square root of 3. So therefore, x is going to equal plus or minus 2I times the square root of 3. So what are the complex zeros of the function? Well, we know that one of them was negative 10, the other one is 2, and then one of them is negative 2I times the square root of 3, and the other one is positive 2I times the square root of 3. So by confirming that, that tells us here, okay, now we know that this is a degree of 4. So if we look at this graph, right, it only crosses the x-axis at 2 points, which means that the other values, okay, are going to be complex numbers, which is imaginary numbers. So therefore, these are our answers. Let's go ahead and put that in. So we have negative 10, 2, and we have negative 2I times the square root of 3, comma, positive 2I times the square root of 3. Check our answer, and there is our result.